Hi, this is Jennifer Brazier, and welcome to Formula Weights and Molecular Weights. I want you to remember that in any symbol on the periodic table, you're going to find two numbers. The smaller of these numbers, the whole number that you see, well, we call that the atomic number. The atomic number gives us the number of protons, and the atomic number increases by 1 with each subsequent element on the periodic table. The other number that's given, usually as a decimal right here, the other number is called the mass number. This number gives us the average mass of the element in units of atomic mass units, really small number of grams. Those are the numbers you want to look at when you're trying to add up the mass of not just an element, but what if we want the mass of an entire compound? Now, if we're getting the mass of an entire compound, you're going to hear one of two terms. You're either going to hear formula weight or molecular weight. Now, one thing I should note, the word weight versus mass, in chemistry right here, there's you can substitute one for another. It doesn't make a difference. So weight for us is going to be the same as mass. Now, what's the difference between a formula weight and a molecular weight? I'm going to be honest, for you, not too much. You're going to do the same exact process whether I ask you to calculate the formula weight or whether I ask you to calculate the molecular weight. The difference is we use the term formula weight if we're talking about an ionic compound, something made of metals and nonmetals. Ionic compounds don't technically come as molecules, they're crystals. So we're just adding up the weight for the formula that's shown. It's a formula weight. Molecular weight is the term that we use for covalent compounds because covalent compounds come as molecules. So we're adding up the masses of all the elements within that molecule. But either way, if I ask you for formula weight, if I ask you for molecular weight, you do the same thing. All you're going to do is add up the individual masses of those elements within that formula. Let's do a couple of examples. What if I asked you for the formula weight of calcium chloride? They call it a formula weight for CaCl2 because calcium chloride is an ionic compound. No problem. Now, if you want to go ahead and calculate the formula weight of this, well, it looks like we're going to need the mass of 1 calcium, 1 Ca, and we're going to need the mass of 2 chlorines. The 2 only refers to the element right in front of it, unless we have parentheses, which we don't here. So we've got 2 chlorine atoms. So you're going to go ahead, you're going to look on your periodic table. For calcium, we see we've got 1 calcium, and the atomic mass of calcium is 40.078 AMU. Now, what about for the chlorine? We've got 2 of those chlorine atoms, and if you go ahead and look at the atomic weight of your chlorine, you see 35.453 AMU. If you add all of those up together, you're going to get a value of 110.984 atomic mass units. Now, if we want to round this, where do we round this? I don't know. Your instructor might have different rules. Usually 1 decimal place is a good place to keep, at least 1 decimal place. So if I go to round right here at 1 decimal place, I look at my 9, and I notice I'm going to have to round up because I have an 8 behind it. So when I round that 9 up, I'm going to go ahead, round my next number, and get 111.0 atomic mass units. All right, that was for calcium chloride. Let's try a molecular weight. So formula weight, ionic compounds. Molecular weight, we're going to go ahead and do that for covalent compounds. The specific covalent compound that I want to go ahead and use is, and I'm going to do this up here, we're going to look at C2H6 ethane. So if we go ahead and calculate the molecular weight of ethane, I notice that I've got 2 carbon atoms. Okay, what else do I have? I have 6 hydrogen atoms right here in my formula. So I look on my periodic table. I've got 2 carbon atoms, and the atomic mass for carbon is 12.011 AMU. I've got 6 hydrogen atoms. Each hydrogen atom has an atomic mass of 1.008 AMU. Now, I need to add up 2 carbons and 6 hydrogens. If I add up, this is about 24 and about 6 more, I'm going to get about 30. If I do it on my calculator, I get 30.070 atomic mass units. Now, if I rounded this to 1 decimal point, I'm going to keep 1 here. I notice that beyond the 0 is a 7. I'm going to go ahead, round up, and I'm going to report my answer as 30.1 atomic mass units. All right, so if you want a formula weight or an atomic weight or a molecular weight, simply add up all the atomic weights, all the atomic masses of the individual elements that are within your formula. I hope that helps. Take care.